This demo presents a long-term, cost-aware AI assistant for road maintenance decision-making. Road maintenance is not a one-off optimization problem. Decisions made today, such as whether to inspect, repair, or defer, affect future actions and long-term outcomes. For this reason, road maintenance can be naturally viewed as a sequential decision-making problem, often referred to as preventive maintenance planning. The goal of this work is to develop an early-stage decision support demonstrator for long-term road maintenance. From a planning perspective, maintenance is modeled as a partially observable Markov decision process, and a long-horizon planner is used to reason about downstream economic consequences. Importantly, this is a human-centered AI assistant. The AI acts as a constrained and interpretable expert in the economic dimension within a human-principal decision process. Engineer acceptance behavior is explicitly modeled using an interpretable logic constructed from engineering relevant indicators. This allows the assistant to adapt its recommendations to human preferences over time. Here we illustrate how road maintenance is formulated as a sequential decision-making problem under partial observability. The true condition of the road asset is hidden. Engineers therefore maintain a belief state over multiple deterioration levels. Inspection actions provide information to reduce uncertainty, while maintenance actions directly affect deterioration, but at higher cost. Each state incurs a different cost, with severe states leading to very large penalties. This structure naturally fits a POMDP formulation. Finally, this shows the human-AI interaction loop. At each step, the AI performs long-horizon look-ahead planning based on the current belief state and provides an advisory recommendation. The engineer decides whether to follow or override this suggestion. The process repeats in a receding horizon manner, allowing the assistant to provide forward-looking, cost-aware guidance while remaining adaptive to human preferences and newly acquired information. This slide summarizes the key parameter settings used in our experiments. We specify condition states, their associated risk costs, available maintenance actions, and the corresponding cost and deterioration dynamics. However, in practice, even when actions have similar costs, engineers may still defer an intervention. For example, when a maintenance action requires expensive or specialized equipment that is not currently available. This is illustrated in the table. We now demonstrate it using a simulated road maintenance scenario. We begin with a human-only decision experiment, simulating an engineer making decisions without AI assistance. The initial asset state is healthy, and we consider a 25-step horizon, representing a 25-year life cycle. The engineer follows a conservative strategy. When the asset is believed to be healthy, inspection actions are repeatedly applied. If any damage is detected, maintenance is preferred. After several inspections, the asset is observed to deteriorate to state 1. Engineers determine that repairing this damage requires expensive and specialized equipment, which will only become available after 2 steps. As a result, the intervention is delayed. During this waiting period, inspection actions are continued to ensure that the asset condition does not worsen. Once the equipment becomes available, a maintenance action is applied, and we obtain the total life cycle cost under human-only decision-making. We now repeat the experiment with AI-assisted decision-making. Initially, the assistant recommends doing nothing, as this minimizes long-term cost under its planning model. However, the engineer follows their own preference and selects inspection instead. The assistant immediately adapts and begins recommending inspection actions. When deterioration to state 1 is detected, the same practical constraint applies. The intervention is delayed while inspections continue. During this period, the assistant consistently recommends maintenance, which aligns with the engineer's intent, even though the action cannot yet be executed. After maintenance is performed, the assistant suggests switching to doing nothing. At this point, the engineer reflects on earlier outcomes. After 12 consecutive inspections with no observed damage, and given the assistant's generally reliable advice, the engineer adopts a new strategy, performing inspections periodically, for example once every 4 steps. This strategic shift reduces the total cost by approximately $3,300, with an acceptance rate of 72%.